Good morning, everyone, people online.
Good morning.
Good morning.
Am I audible to everyone?
Yes.
Yeah, yeah.
Okay, so today we are going to do the revision on stats. Okay, not chapter by chapter. Just touch upon some basic concepts and see. I just want to know how much you know these concepts. Okay, that's the whole idea. If there are any gray areas, we'll do some hands-on. Is my screen visible to everyone? People online, please confirm it.
Yes, sir.
Yes.
Yeah.
Okay. Okay, let's start. So, basic question, what is statistics?
Putting data into a tabular format.
Putting data into a tabular format. Then what is SQL? That is also putting data.
Study of data.
Study of data. Okay, statistics is about data. Okay, not how you put the data. Okay, good. So it is the study of data for getting insights into your data set, columns, whatever it is. Now, there are two types of data that we deal with. What are the two types of data?
With repetition.
No, that is sampling technique. When a client gives you a data, that is the format.
Population.
That is data types.
Population and sample.
No, that is a different thing altogether. That is about the data. Okay. The types of data are raw data and processed data. What is a raw data and what is a processed data? What are the differences between these two? Okay, so first let us look at raw data. What are some of the characteristics raw data can have?
Duplicate.
Duplicate. Duplicates, very good. So there can be duplicates. Very good. There can be nulls. Irrelevant data or repeated data. Irrelevant. Outliers. Anything else? Very good. So wrong format. Okay. So wherever you have any discrepancies with respect to the data, that is called as a raw data. What is a process data? Opposite of all these. Okay. So wherever you have duplicates, you remove duplicates so that you have only one instance. Nulls, you fix the nulls. Repetition or irrelevant data, you can drop those columns. Can you give an example of irrelevant data? Where do you think a data is irrelevant?
Like student roll number.
Okay. Student roll number, irrelevant.
For example, if we are searching for car performance, then chassis number, if we are taking data given it can be irrelevant in that context.
Okay, so sometimes data can be irrelevant based on the context or based on the domain. Sometimes the data is irrelevant because I can extract the data from other columns. Okay, a very simple example. I want to find what is the total cost of a product. Okay, so suppose I have quantity and rate. Okay, so quantity is 5, rate is 20. Then I also have a column called as total, which is 100. Okay, now which is irrelevant here? Total is irrelevant. Okay, in SQL also you would have seen how to design a table. You drop irrelevant columns because this is a calculated field. Okay, so 20 into 5 will give you the same result. So you are unnecessarily creating these kind of features. Okay, so irrelevant. Outliers. We'll discuss outliers in the next session. Then what is wrong format? Even online people, you can please answer. Okay, I'm not asking this question to these 6 people in the class. This is for everyone. Okay, good. So date time is a date time column is represented as a text column. So that is a wrong format. Anything else?
Data set, sometimes the CSV format is not proper because this stuff you have to convert it into text to convert.
Yes, these are typical problems when you download. Everything is in a text format. Even in SQL, you would have seen when I upload a CSV file, a lot of date time gets converted to text. Okay. Sometimes the format is wrong for numeric also. Okay, where I want float, it is not float. Where I want int, it is something else. So these are wrong format data. Now, another area where I will have wrong format is something called as fixed format data. People who have worked with data, you will probably can correlate fixed format data. Okay, now what is a fixed format? Now, let us say that I am working on a telecom project. Now, in a telecom project, there are multiple vendors, there are multiple databases. Okay, so you have a customer database here. You have a network usage database here. Okay, then you have a billing center here. Okay, then you have a problem, the CRM here. So you have different databases. Now, let us say I want the billing information from this vendor. Okay, now the database of this vendor and the database of this customer, do you think it will be the same in terms of the format? It will not be. Okay, customer ID of CRM will match to maybe some other, let's say, customer ID, CID or something, okay, some different names. Okay, the database itself will be different. SQL, Oracle, file server, okay, file system, it could be anything. Okay. Now, these vendors, they agree that if I want something from your system, I need it in a prescribed format. Okay, so the prescribed format, one of the formats that they agree is called as a fixed format. Okay, so fixed format means I'm going to pass the data in a single line. So the first 10 entries of this line, the cursor. So the first 10 entries of the line will represent customer number. The next 5 digits or the first 5 characters will represent some area code. Okay, the next 30 characters will represent the name. Okay, so this is agreed. So 10, 5, 30, then let's say gender. So gender is 1, so this is 1. And then it goes on. So this is a fixed format. Now, for some reason, this vendor is not giving the data in this format. Then imagine what is going to happen when you upload this data into your system. Okay, so let's say that the format passed is 10, 2, 6, 1, and 4. Okay, so where there should be 10 characters, that is going to fit properly. Where there are 5 characters, it will take the first 2, which is the right one. Then it takes the next 3 of a different field. So you end up with a wrong information. Okay, so these are wrong format. So this can cause a problem with your data set. Okay. So process this, you remove all these things and fix the data. Okay. Any questions? Okay. How is data collected? Data collection. Observation. Survey, experiments. Survey. Anything else? Transactional data.
Forms will come under survey, right? Forms.
That is survey. Online survey, forms. So I will put forms here. And then you can also generate data. Reviews, correct. So there are different ways in which you can generate data. What is a typical form of a data? Let's discuss that quickly. What are the different forms of data? There are 3 forms. What are they? 1, 2, 3. Someone told in the beginning. Structured data. Second one, unstructured data, not unstructured, semi-structured, and then unstructured. What is structured data?
The proper format. You have a sequence and everything.
How do you define that sequence?
Fixed form.
Fixed form is not structured.
According to data types.
Okay, I'll give you the example, then tell me the definition. Example of structured data is Excel sheet and SQL table.
we cannot add anything new on the, like in the table.
Why not?
Like no, like it's like
Finish. Karo.
If a syntax is, if a format is already defined to a table, then that is the fixed for that. If you have to add anything, then we have to enter. We can add, but the data will not be updated for the previous records. It will only updated for the record which is added next to it.
Okay, so what has that got to do with the definition?
Like it won't be in a proper data would not be in a proper structured way, because some records will not be having those data which we added, new columns which were added.
No, there we are talking of missing data. You are right. When you start with 10 columns, you have some data. You add 2 more columns, the new rows will have those columns, the previous ones will not have. Okay, but that is missing data. Nothing to do with the structure. Tabular format. Okay. Structured data means where your data is arranged in rows and columns. Okay. You can easily access the table by giving queries, writing queries, or referring to the column names. Okay. That is SQL and Excel. You have headings and easy to access. What is semi-structured? CSV is, you can read a CSV using Excel. So it is actually considered as a structured form.
JSON file or the XML files?
Yes, correct. JSON file and XML file. Have you seen an XML file? What is the structure of an XML or HTML, for example? So you have the main tag. Let's take an example of name. Okay, so this is the outer tag. Then you have the closing of this tag. So name. Then inside this, so this is one structure. Now inside the name, I can have first name, then first name. Then I can have a middle name. So M name, then middle name, then last name, then last name. Then I can have any other name combination. So the entire structure of name comprises of sub tags. So it has some form, but it is not very easy to read. Okay, so this is called semi-structured format. What is a JSON file? Keys and values, pair of keys and values. So this represents which object in Python? Dictionary. Good. Then what is an unstructured data? Correct, free form text. What is the difference between a text file and a free form text file? What is a PDF or a Word document? Is it a text file or a free form text? It's a free form text. Okay. Now, what is the difference between these two? Very thin line of difference. A free form text does not have any formatting. It need not have any formatting. Okay. I can write my first line, leave some 5 spaces, start my next line. Okay. That is free form text. Okay. Now, can I do that in a structured form? No, I cannot leave blanks. Okay. Unless I manually alter it. But generally it has a structure. Okay. So free form text can have as many junk characters as you want, extra spaces, no formatting. So that is the reason why when we do text analysis, text analytics, reading reviews and finding out whether this is a positive or a negative review, okay, we first format the text, mix of uppercase, lowercase, okay, writing in Hindi and English. People do that. Okay, then there are characters which are German specific, Spanish characters, A with 2 dots. Okay, so those are free form text. Okay, now what is a text file then? Text file can include free form text. It can also include the fixed form, which I gave this example here. The fixed form text. This is also a text file. Okay, usually it is a .txt file. CSV is also a text file. Even though the extension is a CSV, but it is also part of a text file format and any other delimited file. Do you always get data separated by a comma? Not necessarily. Some data come with other delimiters like $sign, tilde sign, which is a very common delimiter, tilde, or the pipe symbol. Okay, so customer ID, tilde, name, tilde, gender, tilde. Okay, so because tilde sign is never used in any regular text. Okay, so it is a commonly used parameter. Whereas $ and pipe symbols have specific meanings. So we generally avoid using those things. And even at the rate, ampersand, it has a special meaning. Okay. Okay, any questions from anyone? Clear here? Okay, next. Now we'll talk of data types. So from a statistics perspective, what are the data types that we have? From statistics. Number, numeric, and categories or alphabet? What is it? Character. And we can also have date. When we are doing time series analysis, we do dates. Otherwise, we deal with only numeric and character. Now, this can be broken again into different categories. Character have 2 separate categories. Numeric have 2 separate categories. What are they? Characters have, we call this as NO and IR. So N is nominal data. O is ordinal data. And for numbers, we have integer data, interval data. And R is ratio. Okay. You must have done this in the class. Data types. This comes in chapter 1.
We started with stats, directly variation, distribution, central.
Variation.
Yeah,
Sida. Variation is chapter number 3 or 4.
Variance and standard distribution.
That's why. See, unless you know these things, it becomes very difficult for you to interpret your results in ML. Okay. What is the difference between Okay, character can be of two types. What are they?
Nominal and order.
These are the different types. Okay, but character can have two types of characters. What are they? Strings and category. What is a string data? What is a category data?
String is series of characters.
Okay, category is
Type of single character like gender.
no. I can also have male, female. That is also a category. What are your names? Is that string or is that a category? String. What is your gender? Is it string or category?
Category.
Now tell me the difference between the two. Even category is a sequence of characters.
What is the difference? Category, specified category.
So now the difference is categories are limited. Okay, so you have only limited number of values which is shared for between all the members of the sample or population. Okay, gender, there are only two values. So every member of the sample or population will belong to one of these two, not both. Okay, educational qualification.
Category.
It's a category. You can have only limited number of values. Okay, graduate, postgraduate, doctor, uneducated, for example. So each one of us will fit into only one of these four values. What is a string then? String can have duplicates. It need not be unique. Okay, so every person has a name associated. So that is non-repeating. It is repeating. So that is a string. Okay. Now, when we are dealing with nominal and ordinal, they are usually part of categorical data. Okay. So what is the difference between nominal and ordinal? In a nominal data, order is not important. Order is not important. For example, if you're filling up a form, okay, and you have to fill, let us say, your current city, okay, and there are 20 cities listed, but it need not be in an alphabetical order, okay, at random. So does the order matter here? You have to select your city, your current city. Okay, it need not be sorted. So your job is to pick your city and proceed. So here order need not play any significant role. So that is called nominal data. Nominal is name. So name is significant, not the order. Okay. What is ordinal? Ordinal is order. So here order is important. So score very good, sorry, excellent. The score is 5. Very good, the score is 4. Good, the score is 3. Okay, satisfactory, score is 2. Poor, score is 1. Okay, now here the order is significant. If I put excellent and give the ranking as 1, so will that make any difference? It will be a big difference, isn't it? You are completely reversing the analysis. Okay, so here the order is important. Along with it, the name is also equally important. Okay. So this is with respect to string data. I'll say character data. Clear? Then we have interval and ratio. So interval and ratio are related to numbers. So the characteristic of this is, let us say I have a column called temperature, and I am having the values like this: 10, 5, 0, -5, -10. Now, if you look at this data, do I know the difference between the two rows? The difference of temperature, how much is it? 5. So I know that value, isn't it? Because I have segregated the data based on that difference. So I know the difference. Now there is one important value here which is called 0. What does 0 represent in this? Is it a valid value or is it an invalid or a bad value? It's a valid value. Okay. So wherever I have, so in statistics, we have a term for 0, which is called true 0. Now in this example, can I say 0 means presence of temperature or absence of temperature? Presence of temperature, isn't it? 0 is what? Temperature hai ki nahi? There is temperature. 0 means freezing, isn't it? So that is temperature is there, which is having a value 0, which is freezing. Okay. So true 0 is when there is a 0 and the entity is missing, that is defined as true 0. So here 0 is there, but entity is not missing. So this is not a true 0. So where do you have a true 0? Let us say weight. 25, 38, 14, 0. Now can I say weight is missing? There is no weight when it is a 0. So in this example, 0 indicates true 0. Because 0 weight means weightlessness or there is no weight. So interval and ratio have the same interpretation. The difference is presence or absence of true 0. Clear? Online, any questions?
No, sir.
No, sir.
No, sir.
Okay. Now the next one we have is long format data and a wide format data. A wide format data is what you generally see 99% of the time with your data, where you read from left to right. Okay, SQL table, Excel sheet, anything which is a tabular form, left to right, that is a wide format. What is a long format data? A long format data is read from top to bottom. Okay, so you have, let's say, product P1. Okay, so this is, let's say, product A. Price 300. Then product 1. This is price. So product 1, color blue. Then product 1, let's say availability, yes. Okay, so I'm having one row where every row has product name, the feature of that product and the value of the product. Then say okay, next, population and sample. What is a population? What is a sample? Very simple question. What is the difference?
Sample is small data set of population.
Sample is?
Small data set taken from population.
Small data set taken from population. Okay. How do you represent a population and a sample in stats? So there are two main measures that we use in statistics. Whenever we are talking of any data, we talk of two main things. One is the mean. The other is deviation. Okay. Or we will say standard deviation. So when I'm talking of a population mean or a population standard deviation, What is that mean and deviation? What are they called for statistics? That is a symbol. But what are they known as? No, not definition of mean. There is a name for population mean and population standard deviation. They are known as population parameters, correct. Population parameter. And when I'm talking of a sample mean and sample standard deviation, they are known as sample statistic. Not statistics, okay? Statistic. So how do you represent a population parameter mean? What is the symbol for that? For population, mu. And for sample, X bar. What is the symbol for standard deviation? Sigma. And for sample, it is S bar. Okay, small s. Okay, not capital S. Capital S is something else. So mu and sigma are population parameters representing mean and standard deviation. X bar and small x, again small x bar and small s bar represent the sample statistic. Okay. Now we'll come to the main part of stats. What are the two types of statistics? What are they? What that comes under this, but what are the two types? Online, anyone? I'm surprised why this was not covered. Descriptive statistics and inferential statistics. Good. What is descriptive statistics? It describes the data. Simple. What is inferential statistics? It tells about the population data by analyzing the samples from the samples. Okay. Descriptive is either you can analyze your sample or the population. What is my data telling me? Whereas inferential is always based on the sample, which tells how my population is going to be. Okay. Can you just open that window, please? So under descriptive, what are the different measures we have? Number. What is it called? Measure of? Central tendency. So measure of, just write central tendency. Under central tendency, what are the different measures? Mean. We have geometric mean. Then we have weighted mean. These are the main measures that we use. Okay. Mean is the arithmetic mean. GM is geometric mean. WM is weighted mean. Then we have median. And then what is the second measure?
In central tendency, quantiles also comes.
No, central tendency is finding the middle value. What is the second measure? Measure of dispersion. Or it is also known as measure of spread. So under this, what is the first measure?
Variance.
Yeah, variance is there, but the first one is range. Then we have variance. Then
Standard deviation.
standard deviation. Okay. And then of course you have quartiles. Then the last one is measure of association. Association has covariance, then correlation, then in correlation itself there are a couple of categories. You have rank correlation. So if we have time, we will do this. That's not really important. These two are the main: covariance, correlation, and coefficient of covariance. Coefficient of variation. These are the three main measures. Then inferential statistics. There are only two measures in this. What are they? Estimation . Estimation is, again, it has two categories. One is point estimation, and the other is range estimation. Okay. And the last one is under inferential statistics. That is this hypothesis testing. We'll cover that. I'm just giving you the headings first. We'll discuss all these. So hypothesis testing, what are the different hypothesis testing that we have? One sample, then two sample, then n sample. Right? So one sample is for population and sample. Two sample again for population and sample. N sample is for. There are two variations in N sample. What are they? ANOVA. And what is the next one? Chi-square. Now tell me, out of all these things, what are the measures you have done? Or are you aware of these things, these measures? You know where they are used, why they are used?
Why and where we are not talking about it. But on the tool level, we have done.
Okay, we'll try to finish. Hypothesis will take some time. At least we can do till estimation at least today. Okay, we'll do this in Excel. It will get done faster. So let's open Excel. People online, any questions from you?
No, sir.
Okay. What is the advantage of a mean? And what are the disadvantages of a mean? First, let us discuss that, then we'll do that with an example.
Find the central value.
Okay. Central value, correct. Advantage?
Measure dispersion from the mean.
Measure?
कितना dispersion होगा mean से वो समझना है.
Dispersion की बात ही नहीं कर रहे हैं ना, mean की बात कर रहे हैं. Dispersion is the next measure. Mean will consider all the values of my sample. Okay, so that can be an advantage also, disadvantage also, depending upon the size. But it takes all values into consideration. Hey, what is the problem? Okay. Then, what is the disadvantage of a mean?
It can differ if there is an outlier.
Good. So means can change when you have an outlier in the data. So we can say that mean is not a stable measure. Okay. So now let us do this with an example. Are you all familiar with Excel, basic Excel? Everyone? Okay, good. So we'll generate some data points, some 50 to 60 points. Okay. So there is a function called as rand array. RANDARRAY, rand array. Okay, just check if you have this in your Excel formula. You have, okay. Now rand array will take a couple of parameters. How many rows of data you want, how many columns of data you want, and whether you want integer or non-integer. Okay, so I'm going to generate 10 rows of data, 10 columns. So I'll get 100 values. And I'm going to take what is the minimum value. Okay, so let's take my sample from 1 to 100. And then give me integers. So I'll get random numbers between 1 and 100. Okay. If you don't have this function, rand array, you can do this. There is a function called as random. Rand between. You have function rand between? You have rand between? Rand array. But is this function there, rand between? So use this function rand between. So this will ask you, what is the range? So what is the smallest number you want? What is the highest number you want? So put 1 to 100. So this will generate one number. Now copy this number to a 10 by 10 matrix. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then you can generate your array like this. this minimum number, of this maximum number. Whatever number you want to enter. Now copy this to the data matrix of the table of numbers. Number creation, this is over. Now, is this number dynamic or is that static? Dynamic. Okay, so that could be a problem when I'm doing some calculations. So I want to create static numbers. So how do I convert this? Copy this. Control C for copy. Then right click, there's an option called paste like. So paste as value. Okay, use that 1, 2, 3 option. So paste as a value. Now you will get static numbers. Sorry? Second floor. Okay. Now, how do I know whether it is static or dynamic numbers? Look at this part, this address. This place will show you the same value what you have here. Okay, now if I keep the cursor here, it will show 45. If I move the cursor, it will show that value. That means it is static value. If I have a dynamic value, it will show the following. Okay. Now let us calculate the mean without outlier and we'll see how the mean changes when I have an outlier. Okay, so let me. So the formula for mean in Excel is called average and select the sample for which you want to calculate the average value. So for my sample, it goes from this cell to this cell. Okay, so select the entire range. So the average I get for this sample is 48.35. People online, are you able to create the data?
Yes.
Ankita, Chintamani, Kamlesh, Keshav, Brinal, and Yogini.
Yes, sir.
Okay. So it is 48.35. So I'm just going to write this number, 48.35. Now let me introduce one outlier to my data set. You will probably get a different value because it is random number. Okay. So now I'll use, let's take the first number. Okay. So I have 44. So I'm going to put this number as, let's say, 440. Okay. So you can change any 1 or 2 values. Okay. Now I'm going to calculate mean with outlier. So formula is the same, average So now you can see the difference between the two values. So this is my outlier, 440. And if this number increases, let's say 4400, it will have a drastic effect on the overall mean. Clear? So how do you detect outliers? You are given a data set which has, let's say, some 20 numeric data. How do you detect the outliers? One is by the maximum value. Okay. Other means, what are the other ways in which you can detect? You can
And we plot the graph.
By plotting the graph. Okay. So one is by finding what is the max value. So you can put max and min, because even outlier can be a minimum also, isn't it? You can have a minus 22. So you can put the maximum value and minimum value. So the function is max. So here it is obvious, it is 4400. And the minimum value is min of . So minimum is 1, max is 4400. So now you can see there is an outlier. Are all outliers necessarily are outliers? I mean, are all extreme values an outlier? So how do you determine that this extreme value is an outlier? So here 4400, why do you think this is an outlier? It is in the? Not in the range. Okay, so here I am assuming that it is a student mark. Okay, which can have a minimum of 1, maximum of 100. So anything which is beyond this is an outlier. So here it is definitely an outlier. Okay. Now assume that this number is not a mark but a salary. Can you still say this is an outlier? No. Okay. Because there can be people who can have this kind of a salary. Can you compare the salary of Ambani and a school teacher and say that his salary is an outlier? That is wrong. Okay, because you can have a range of salaries that go from very high to very low. Okay. So let's plot it and see that how to identify outliers. So you can select this data and there's an option called insert chart. So go to this insert option and select the chart and select whichever chart is applicable. So here, if I select line chart, scatter. So if I select the scatter plot, you will see one dot right at the end. Okay, so select the appropriate chart, whichever you think is representing the data best. So if I take this, okay, so I'll have this extreme value. Now, second question, how do you fix the outlier? You have identified the outlier. Now the challenge is how to fix the outlier. So before we do that, let's understand what are the other measures. Then we'll have a good understanding which value will be the, or which measure is going to be the best to fix outliers. Any questions online, people? Okay. So next we'll go to the second measure, which is called geometric mean. Now we'll see weighted mean and then we'll go to geometric mean. So weighted mean is calculated when we are given a certain percentage to that particular value. Okay, in a regular arithmetic mean, equal weightage is given to all the values. Whereas in a weighted mean, for that particular value, I give a certain percentage. Okay, just to give a very simple example. If I have, let's say 5 subjects, and I have to calculate what is my average score. So my score will depend on, let's say, assignment. Number 2 is going to be quiz. Number 3 is going to be projects. Number 4 will be, let's say, mocks. And number 5 will be the, let's say, some exam, some test. Okay, now each of these are out of 100 marks. Okay, now if a student scores something like this, 50, 60, 60, 60, and 50. So what will be the average? Sum total of this. So sigma divided by 5, correct? This is what we did just now, arithmetic mean. But I don't want this calculation. I want to give certain percentages to each of these. So if I give assignments carry 20% weightage, quiz carries 5% weightage, projects carry, let's say, 35% of the total. So 35 plus 5, 40 plus 2, 20, 60. So mocks will carry 15% weightage. So 75, and then test will carry 25% weightage. So this adds up to 100%. Okay, now this is going to be the average mark of the student. Okay, so now what do you do? What is 20% of 50? So this is 10. What is 5% of this? So 5 by 123. 35% of this. So around 18 or 19. Let's put 19. So this is 15. And this is, let's say, 13. Okay. Now you add up all these numbers. So this becomes my average score, average weighted or average weighted average score. Okay. So we'll do one exercise based on this and then compare how different is weighted average and the regular average. Is there a big difference or is the difference insignificant? Is this clear? Online people, any questions on weighted mean?
No, sir.
No replies. Okay. So let's do this. So let's put names. This is first student, second student, and third student. Let's do it for 3 people. And let's put the scores. Score 1. Score 2, score 3, score 4, and score 5. Let's put some random values, 65. Score. And the weights that I'm going to take. So for the score, not score 1. Okay, score 1, the weight will be 15%, 5%, 55%. So 15 plus 5, 20, 20 plus 5, 55, 55 plus 15, 70. First calculate what is weighted mean, and then we'll calculate the regular mean, and we'll find the difference between these two. So let's do the first calculation. There is no inbuilt formula. We have to do it manually. So for the first one, it is so 15%. So 65 multiplied by 15% is how much? 0.15 plus the second score is 80. So C2 multiplied by 5%. So 5% is 0.05 plus the third score is 67. So this multiplied by 35. So 0.35 plus the next one is 79. So 79 multiplied by 15% is 0.15. The last one is 64, which is this one, multiplied by 0.3. So 68.25. So you can drag and drop to get the remaining values. So for the second student, it is 80.85. Third one, 78.65. None? Now find out how different is weighted mean and the regular mean. So I have created one more column called mean. So if you just take the average, so here we can see that there is a slight difference in the two means, weighted mean and the regular mean. Okay. This is entirely dependent on the domain. If nothing is given, you have to take the regular arithmetic mean. Now there are cases where we want to give certain weightages to some values. Okay. It's not always that everything gets the same weight. So in that case, obviously, geometric weighted mean. Now we'll see what is the next measure. So geometric mean is used in situations where there is a lot of fluctuation in the data. Okay, for example, let us say that you are investing some money in a bank, okay, and you are getting simple interest. Okay. So in the first year, you invest some money. Let's say you put in 100 rupees and the interest amount is 5.5%. Then in the second year, the interest rate becomes 6.1. Then in the third year, the interest rate drops to 4.7. And then again, fourth year, the interest rate comes to, let's say, 4.9. Okay. And we'll take just one more number. Fifth year, it comes to, let's say, 3.85. So there's a lot of fluctuation in the interest. So the question is, if I save my money at the end of the fifth year, I get some money. So the bank has to say, what is the average money that you save, or what is my average savings? So how do I calculate my average saving when I have these kind of fluctuations? I can use the regular mean, that is one way, but a more accurate measure is the geometric mean, which is calculated as the multiplication of the number that you want to calculate the mean. So let's say the mean I want to, the value is savings. So saving 1 multiplied by saving 2 multiplied by saving 5. Okay. And then calculate the nth root of the multiplication of all these values. So this will give me fifth root of or 1 by 5 of S1 into S5 because I have only 5 entries here. Clear? So once again, we'll do geometric mean, find out what is the central value. We'll use the regular mean to find out what is the central value. Compare the two means. Let's input some data. Here 1, 2, 3, 4, 5. So let's call this as the principal amount. Let's start with 1000. This is the interest rate. This is the interest amount and this is the savings. So let's take the interest rate for the first year as 6.5%. For the second year, let me take 5.25. For the third year, 5.7. For the fifth year, 4.8. And then 5.01. So what is my interest amount at the end of the first year? So that is going to be on 100 multiplied by okay. And what is my total saving at the end of the first year? That is going to be principal plus the interest amount. So that is my amount at the end of the first year. Now for the second year, what will be the principal? That is the saving amount. So I'll put equals the saving. So I'll get 1065 as this starting amount. And now I can simply drag this formula. This one. Then pull this formula down here and pull this formula for the next one. Okay, now I want to find out what is the average savings. So I can use two measures. One is the regular average, which is the mean value. And the second one is I can use the geometric mean. So geometric mean, the formula is multiplication of all the values and then the nth root. So here n is 5. So SQRT, that is the formula, square root of multiplication of all this. So this multiplied by this, multiplied by this, multiplied by this, multiplied by this, comma, 1. Sorry, not square root. Okay, then I'll just show you one of the formulas, geo mean. You can use this. Okay, geo mean is one function that you can use directly without having to multiply. So select the range. So the average value is 1180.2. Or if you don't want to use, you want the go by the formula, you can use not square root. I made a mistake. It is called power. Okay. So power of multiplication of these numbers okay. So value 1 multiplied by value 2 into value 3 into value 4 into value 5 raised to the power 1 upon 5. So this is 1180. So we'll get the same result. Now compare this number with the regular average and see if there is a difference. So I can use average. So you can see that there is a difference of 3.2 rupees for every 1,000 rupees. So this is a big difference. And anyone from finance background? Anyone with a finance background online?
No, sir.
Yes, no?
No.
Okay. So they can probably tell whether the difference of 3.2 for every 1,000 rupees, is that a big amount or a small amount? I feel this is a big amount. Now, if you multiply this and talk of crores, okay, so this really becomes a huge number. So banks, they generally use the geometric mean to tell what is the average of things. Okay, it is not an arithmetic average each time. Clear? Online, any questions from anyone? Are you able to do the calculations?
Yes, sir.
So we have done mean, geometric mean, weighted mean. Now we'll come to Median. What is median? Number of
Repeated in value.
number of repeating values. But that is mode.
So we are saying when we put the numbers in this equal to this vector is
Alright. So
Middle number.
Yes, tell me.
Number.
Right. So median is also another measure that is used to find out what is the central value of a given sample. So what is the difference between these two? Mean is also doing the same thing. Median is also doing the same thing. So why do we need two measures to do the same thing?
Median is not vulnerable to the outliers and
Correct.
mean is
Good. So medians are not that sensitive to outliers compared to means. Okay. So median is a bit lengthy in terms of calculations because it needs the data to be in a sorted order. Okay. Either in the ascending order or in the descending sequence. That is the first criteria. What is the second criteria for calculating the median?
Order or even number of
Odd and even. Okay, how many entries are there? If it is an odd number, then it is n plus 1 by 2. If it is an even number, then it is n by 2 plus n plus 1 by 2 position. And then you find out the mean. And another difference is mean calculates the value directly, whereas median is, if you look at this calculation,
it gives the point.
Very good. Median is positional based central value. Okay. So median gives the position, and at that position, what is the value? That is median. Okay. So we'll take the same data that we had for mean. Need to calculate it again. This value was, I think, 44. Let's retain that. Now we can calculate the median. And we'll also find the mean and compare the differences between mean and median. And we will. This is with outlier. This is with outlier. Without outlier. So this is my data that has no outlier. So I can directly use the formula median and see what is the value. So which is 46. Averages. Have you done these calculations by hand in the class? You want to do it, or is this okay? If I have to do this, it will take another 2 weeks for me to finish the entire thing. I'll give you, you can look at your notes. If you have to do the manual calculation, by hand.
You can give it the formula.
Formula I'll give you. So for median, first thing you have to do is sort the data. And number two, count the number of entries. So when the entry is an odd number, then the median is n plus 1 by 2th position. Okay, just to give an example, let's say the numbers are 1, 2, 3, 4, 5. Okay, so 1, 2, 3, 4, 5. So what is the value of n here? 5. Okay, so what is the median? 5 plus 1 by 2, which is third position. Okay, which is n plus 1 by 2th position. Okay, it is not the number. Okay, let me change this and put 10, 20, 30, 40, 50, just to ensure that you don't get confused. N is 5. So what is median? 5 plus 1 by 2th position, which is the third position. What is the third position? 30. So median is 30. Okay, this is when the entry is odd. When the entry is even,
n by 2 plus.
okay, so you will take the n by 2th position plus
n plus 1 by 2.
N by 2 plus 1th position divided by 2. Okay, so do the same calculation. 10, 20, 30, 40, 50, 60. What is n by 2? What is the value of n? 6. Okay, so n by 2 is 3. So what is the third position? Value is 30. So 30 plus n by 2 plus 1. So n by 2 is, actually bracket is in the wrong place. This n by 2 plus 1. So how much is this? 31st position. Okay. Fourth position. So what is the fourth position? 40. So 30 plus 40 divided by 2, which is how much? 35. So if you look at this value, 35 is right in the center. So 50% data is to the left of the outlier, to the median. 50% of data is to the right of the median. This is the formula. Okay, so now we don't have to worry about all these calculations. This is just for your understanding how it is done. So without outlier, the median is 46, mean is 48.35. You can see the difference in the two values. Now with outlier, so let me change this to 46, 48.35. Now let me put this value as an outlier for 400. And let me calculate the median first. Now see the difference and tell me which is a more stable measure to find the central value, median. when you calculate house prices, when you want to, let's say you are doing a survey of house prices in a certain city, will you say the average house price is so much or median house price is so much? Any other answers online? The average house price in Pune is 75, let's say for a 2 BHK flat is, I'll say 70 lakhs. Is this a right state? No, I won't say right. Is this appropriate or median house price is 70 lakhs? Which is more appropriate?
Average.
Okay. Online?
Median.
Why median and why mean? Both are acceptable. Okay. So which is more appropriate? That is the question, huh?
So if we say average, the price can be high as well. Depends on what area you want to flat to be in. So it can be for 25 also, it can be for more than, let's say 70, 80 lakhs as well. So average is appropriate.
Average takes consideration of many different values. Well,
Whether it is less or whether it is high, whether the price is minimum or whether the price is.
Now, in a property, let's say you are considering all areas of, let's say, Pune. Can there be properties which are very highly priced? So in that case, can I use mean? Or can there be houses which are, the prices are very less?
still survey will be using mean.
Median will give the
Like the middle value of entire won't be appropriate for entire.
Okay.
they will consist of only one or two outliers where the range will be either high or either low. But mean will give us the combination of all the higher and the lower values. So it will be easier that okay, if my budget is around 50 lakhs, so I'll see what is the range and what is the mean is coming about 55 to 60, or less than 50, 55, something like that. And when we calculate median in that way, we'll get a fixed value. Like suppose the outlier it will come out to be some values around 60, 70. So that will be like getting it no different. You will be getting an average of that.
Okay. Online, someone said median. So why median is appropriate?
I think median will give the value which is very close to normally distributed flat price range. So it would be more accurate because since there are a different number of flats which are within the limited price range. So median will be close to that price range.
So you say median is appropriate. Okay, let's change this number and make it 120. Okay, these are all property prices and everything is in lakhs. Now tell. Okay, this has to be changed. So this is with. Okay, let me remove this for the time being. This thing. Which is appropriate now. I have properties which are the maximum is 1.2 crores, and I also have a house for 1 lakh, which is very unlikely. So let's make it 10 lakhs. And even 5 lakhs, I don't think even a kitchen won't come for 5 lakhs. 25. Not it. You can actually use both. Okay, it will depend on which area you're looking at and what is the distribution of the values.
Sir, if we are looking only for a particular area, I think median would be more appropriate. But if overall Pune is to be seen.
If you're looking at a particular area, then which one is more appropriate? In that case, mean would be more appropriate.
Yeah.
If you look at Shivaji Nagar area, prices are approximately similar. Okay. That's not a big difference, huge difference. But if you are comparing two areas, let's say Shivaji Nagar and let's say Baner, or maybe Shivaji Nagar and Hadapsar. Okay, from 3 different places, 3 different values. So maybe that area is more expensive than this, or maybe this is more expensive than Hadapsar. And if you go further east, you have values which are further down. This side, western place is more expensive. So you'll have fluctuations. So in that case, median will give a much better representation of the values. Okay, similar area, similar distribution, mean. Okay, again, it is in theory it works, but in practical you have to see the data and then select whichever measure is appropriate, and then based on the domain you have to select the measure. Okay, so everything is domain dependent in statistics. Okay, the last measure is mode. What is mode? What is the use of mode? Okay, one way is you can replace outliers or missing values. What is the problem with mode? Is that a stable measure? No. Why not?
We have to give about 1 frequent values.
We can only figure out the maximum value used in the particular data set, maximum time that value has been used in that set. And if we try to calculate the average or other things, we'll get average out of it. Mode will just give us the maximum time that value has been used.
Okay. So where lies the problem in that?
Like, so let's take example of property.
Okay.
Suppose if I use 1 crore 7 times. So the mode will give us 1 crore.
Correct.
But if we want to get what the average of it, like not just the average, just the basic understanding of the data, like where we are getting, I will say the average of it. Estimations will not be used because the maximum value will be showing us 1 crore. But there will be some values where it will be like 50 lakhs, 70 lakhs, somewhat later. So that value will not be coming.
So in that case, don't use the mode. That is why we have so many measures. But we have a very specific measure to calculate the repeating values. One case is I can fill nulls or missing values with the mode. Okay, that is one very simple way of doing it, even though that is not that may not be the appropriate way always. Okay, this is more like putting a plaster. Okay, right now you are okay. Okay, which is fine. See, the problem with mode is, I'll give an example. Let's say you have a boutique. Okay, you are running a shop and you get You have 6 different colors of dresses. And you want to find out which color is sold the maximum so that you can have more of those colors. You want only one color. Okay. Now let's say in the last 1 year, you have sold 100 different dresses and you have 6 colors. So we'll put V, I, D, G, Y, and R. Okay. So out of 100, so this is 5, this is 6, this is 21. So this is how much? 11, 29. This is 11 and 29. How much? 40. Okay. 60. 50. What do you get here? If I calculate mode, you will get 3 values. But I have to find only one number or one value. Okay, so mode can have these kind of repetitions, which is called bimodal. Okay, so sometimes mode is not always a good measure to use. Now imagine if I had 6 colors and the distribution was like this. 2, 3, 1, 1, 1. So 3 plus 2, 5, 6, 7, 8. Can I say 92 is an outlier?
Yes.
Yes or no?
Yes.
Why? I'm getting the mode, no? Highest count. So is mode, is it get affected with outliers? No. So here outlier is actually working, isn't it? Even though the percentage of distribution is not unique, it is not evenly distributed. Okay? There is a high percentage for one, the others are on the lower side. So leave that aside. So can I say 92 is an outlier? No. Okay, but which is the highest selling color? The red color, 92. Okay. So I don't think there is anything to do as an exercise, just a matter of counting. How do you count it? In SQL, it is very simple. You can do group by and then count. Okay. Okay. So now mean, median, and mode. What if all these values are equal?
Standard deviation. This would be normal distribution.
Very good. When all these are equal, I get something called as a normal distribution. So, okay. So if I have to find out how these values are distributed, so this is a normal distribution. Okay. So this is the mean, which is the same as median, which is the same as mode. But over 99% of the data will always have a skewed distribution, because in real life, normal distribution is very rare to get. So you will have distributions which are skewed. So what are the 2 different types of skew?
Right and left.
So left and right skew. Okay. So how do you identify the left and right skew? Okay. So let's say that I have a data like this, distribution like this. Okay, what is this point? The highest peak, highest point in the peak. This is mode. What is median? The central value. So central value will be here. And this will be the mean. So mean, median, mode. So the area to the right of the mode, if that is greater compared to the left side, this is called right skew. When you are well prepared for the test and the average score is 50, so most of the students fall in this area. Okay, when you don't prepare well for the test and the average score is 20, so where do you fall in that case? So this is the left skew. Okay, so this is the median. Sorry, this is the mode. This is the median, which is the central value, and this is the mean. Clear? So your real life data will either have right skew or left skew. Very rarely you will have even distribution. So when we talk of distribution, I'll just quickly touch upon what are the different types of distributions. Okay, clear here? Online, any questions?
No, sir.
Okay, we'll take a break now, 11:20. Let's meet in 15 minutes, and then we'll continue.
सर आपके बॉलीवुड लिंक शो कर रहा तो जो का दूसरा एसक्यूएल का वो बता रहे थे एसक्यूएल की जो फाइल्स आप बोल रहे थे उसमें अपलोड कर दो कुछ भी अगर आपको अपलोड करना होगा तो उसमें अपलोड कर दो
Send me the link.
मैं आपको व्हाट्सएप किया आप ऊपर देखो उसका एक्सेस नहीं है it's my personal
Okay.
मेरे को मैं एक्सेस अपनी ईमेल आईडी पे एक्सेस करती हूँ
मेरा ईमेल आईडी है ना, लास्ट टाइम लिखा था ना इधर।
सही होगा वैसे मैं वो पब्लिक डोमेन नहीं करता हूँ जो वो फोल्डर का लिंक है पब्लिक डोमेन में वो कोई भी एक्सेस कर सकता है ठीक है तो होगा कल एक बार चेक करें
मेल कर दो वो लिंक।
मैंने
व्हाट्सएप किया क्या? अच्छा
को मैसेज किया
ओके। केशव Shall we start? So the next measure that we are going to see is measure of spread. Measure of dispersion or measure of spread. So this measure is used when we want to find out from the central value or from the mean, how is my data distributed on both sides. Okay. So in the first, we have a range, which is the measure that finds how my data is distributed. Okay. So range is calculated by taking only two values. What are they?
Lower limit of
Correct. The minimum value and the maximum value. So if I say that my minimum value is 5 and the maximum value is 70, what does it mean?
65. Min.
Yeah, the range is 65. It is max minus min. So range is 65. So what does this mean? What do you interpret from this?
There can be values ranging from 5 to 70.
Correct. So it means that my data is lying between only these two numbers. Okay, nothing more, nothing less. Okay. What is the advantage and disadvantage of using range as a measure? Let's talk of advantages. Do you see any advantage of using the range as a measure to find the dispersion?
Less or no outlier.
less data to calculate.
Less data. You are only dealing with two data points. What is the disadvantage?
Cannot be appropriate. And trustworthy. Trustworthy.
Yeah, when is it not trustworthy?
Skewness.
No, skewness we cannot calculate with just two values.
When the from his point, data is not equally distributed.
Okay, correct. So when is this not appropriate to use? Correct. When you have outliers. Okay. So assume that I have marks here, and instead of the 70 as the maximum, I have 700. Okay. So how will you interpret this range? My data lies between 5 to 700. Is this right? Is this interpretation right? No. Okay. So range cannot be used when you have outliers in the data, just like mean. Okay. You will get a wrong result, or an interpretation will not be appropriate. So let's calculate the range. So it is very simple. Find minimum value, maximum value. That's all. So let's take the same data from our previous example. In fact, I'll do it here itself. So to calculate the range, I want So minimum, maximum, and range. So this is min of this is so min is 1, max is 120, and the range is max minus min, which is 190. So in this example, assuming that these are property prices, then this range I can use. If these numbers represent, let's say, a score, spending score, credits, not credit score, spending score or marks, or some other score which ranges between 1 to 100, then this is not a right measure to use. Okay. Online, any questions? Chintamani, Kamlesh, Keshav, Mrinal, and Yogini. Okay. So now we'll go to the next section, which is the second measure of dispersion, which is called quartiles. What are quartiles? Into how many parts?
4.
4 parts. Are they equal parts?
Yes.
Okay. So we have 4 parts. Not P4, sorry. So if I calculate my first quartile, what does, let's say this gives some value. Okay, I'll call this value as Q1, some number. Okay, let's call this as N1. This is N2. Now I get some value for Q1. Q1 equals N1. So what is the meaning of this number N1? What does this indicate?
First, 1/4 of the data.
1/4 of the data. Okay. So if I calculate the quartile here, does this indicate? So this is, these are 100 records. So can I say the first 25 records are quartile 1?
Yes.
Sure?
Yes.
Is this how it is
No.
interpreted?
Yes. Then we can say it is
So how do you define, or how do you interpret the value N1? Let us say, okay, we'll do this example. So I'm going to calculate quartiles. So this is Q1. What is the other name for Q2?
50%.
Other name.
Me.
It is 50%, correct. Quartile 2 is also known as it's a specific name for that. It is called median. Okay, so we also refer to quartile 2 as median, what we did just now, same. Okay. So how do you calculate quartiles? So first, assume that this is my data set. So I'm going to find quartile. So there is a function called QUARTILE. So we can use this exclusive function and then specify Oh, sorry, I want to also give the data range and for which quartile I want. Okay, so 1, 2, 3, 4, those are the values. 1, 2, 3, sorry. 1 is quartile 1, 2 is quartile 2, 3 is quartile 3. So I'll give 1 here. So this is going to give me a number 25. What does this 25 represent? Average of first 25 numbers. So it is not average. This means that 25% of the data lies between, yes.
We have an intervention, I guess. It's 0, 4. Yes. So you were being
Yeah, but that was after the class, isn't it? No?
After the class, no. 12 o'clock, but he was not being informed.
Do you know about it?
Yeah, it was after the class.
12 o'clock, right?
Yeah. No, after
one. And just
one hour.
We have a long way to go. One second.
Actually, we as a placement team, we got the calendar, we got the time and the date today.
Okay, hold on. Okay, I'm just seeing this message. It says kindly stay in the classroom after your session.
What has happened is we got the calendar and
Utkarsha is on the 3rd floor. You can talk to her.
we went to first floor, she got home. If you get how much time it take? I'll take 1 hour. Half an hour
क्या करना है? On this? You want that?
half an hour, 45 minutes.
I will ask them what they want.
We can complete
Okay. We'll complete this. Okay, give us 10 minutes. I'll complete this and. Oh, yes, time. Anyway. So this 25 represents 20. It's a distraction. I get totally. So 25% data lies between what and what? Between the minimum and Q1. Okay. So the minimum can be 0, it can be 1, it can be any number. Okay. So that is why I put this minimum here. So it lies between 1 and the value which is in quartile 1. So in this case, which is 25. Now you sort the data and find out how many data points are there between 1 and 25. You will find approximately 1/4 of how many entries are here? 100. So 25 points will be between 1 and 25. Okay. Q2, also known as median. Let me write it here.
Why do we call Q2 as a median?
Why? Because the formulas are similar and it gives you the same result. N plus 1 by 2. For Q1, it is N plus 1 by 4. And for Q3, it is N plus 1 into 3 by 4. So median, the formula is quartile. So take the same data. So this is A1 and it is J10, 2. Okay. So the value is 47. Now look at this value here, 47, right at the top. What is it? And look at this value. Okay, so quartile is the same as median. So both are having the same number. So what is the interpretation of quartile 2?
It lies between Q1 and Q3.
What lies between?
Q1 to Q3 data points.
That is IQR. Q2 47 means half the data or 50% of the data lies between minimum and 47. Okay, so 50% data lies between minimum and
Sir, the minimum will be Q1, right, for quarter 2.
minimum value of the data set. Okay. Q3, the same formula, quartile.exe. The range is A1 colon J10, 3. So here the value is 72. So what does this mean?
75% data lies.
75% data lies between minimum and the value represented by Q3, which is 72. And there is nothing called Q4. That's the entire data set. Okay. So this is the distribution of the data. Where is the maximum distribution in any distribution in any data? Between Q1 and Q3. Okay, so that is called IQR, interquartile range. So which is Q3 minus Q1. Do you want these files? Should I save it or are you doing this? If you don't, in case you missed it, you want it, then I'll save it. Otherwise, I'll discard this. Just let me know.
Save it.
So what is IQR? What is it? 50 minus 1?
Interquartile range. IQR. Interquartile range is the difference between Q3 and Q1. The distribution. Sorry, I didn't get it. Repeat.
You said something. The maximum thing will be between Q3 and Q1.
The maximum distribution of data. Where do you have it? You will have it between this range. What do you get if I have values that extend on both sides of the quartiles? To the left of Q1 or to the right of Q3? What are those values called? Good, outliers. Okay, so I can have outliers to the left, which are negative outliers. I can have outliers to the right, which are positive outliers. How do you identify outliers? Okay, how do you plot the quartiles? Using the which plot?
Line box.
Box plot. Isn't it? You must have done this in Python probably.
Yes, sir.
Visualization. So how does the box plot look? So you have a box like this. And then you have how many vertical lines?
1.
1 vertical line.
3 lines. Okay, one for each quartile. Isn't it? Yeah, this is visible. This is the quartile 3, but technically there are 3 lines, Q1, Q2, and Q3. Then there are 2 more lines that you see. What are they called?
Median.
This is median. There are 2 more lines that you see in a box plot. You will see something like this. This is called the left whisker. And this is called the right whisker. Okay. Now, what is the meaning of these whiskers? The left whisker is the minimum value of the data, which is not an outlier. Okay. This is minimum value, but not an outlier. And the right whisker is the maximum value, which is not an outlier. Are you getting this? So anything that lies beyond the left vertical line or the left whisker, and anything that lies to the right of the right whiskers, they are known as outliers. So if I extend this line, and if I have a dot here, what are they? Right outliers. And if I extend this line, and if I have dots here, points here, these are left outliers. Okay, so let's say that in this data, I have a value called -15. Is this an outlier? Yes, that will fit here. And if I have a value, let's say 750, where will this line fit? This point fit? It will be somewhere here. Okay. So what determines these left and right whiskers? How do you set the limit for that so that you can identify the outliers? So we have a formula for that. Left whisker is calculated as quartile 1 minus 1.5 times IQR. And the right whisker is calculated as quartile 3 plus 1.5 times IQR. Okay. Now, one thing to remember is this formula that you see, this value called 1.5 is a customizable number. Okay. So this is only when things are good, 1.5 can be used. If you have a certain data set where you feel 1.5 or not 1.5, a certain value which is shown as an outlier is not technically an outlier, you can modify this formula and make it into a bigger or a smaller number to suppress the outliers in the box plot. Okay. So this is the default formula. You can change it according to your domain data. So in this example, if I use this number to find out what are my left whiskers and right whiskers. So here I'll get left whisker equals quartile 1 value minus 1.5 times IQR equals 25 minus 1.5 multiplied by So the value is minus 45. क्या हुआ? And what is the right whisker value? Quartile 3 plus 1.5 multiplied by AQR. So which is 142.5. Okay, so right whisker 142.5 means the maximum value of the data set, which is not an outlier. So anything that is till 142 is considered to be a normal value. Beyond 142, it is an outlier. So here I can see that there is no outlier in this data. But if I have a value which is 160 or 200, it is going to be calculated as an outlier. Online people, any questions, any doubts? I think we are here for the session. So online, we are going to stop the session here now because you have another session, placement session that is going to be conducted by a different faculty. So you have to attend that. It will be about an hour session. So we will stop here today. If you have any questions, let me know. Tomorrow we'll discuss those things and then go to the next chapter. So thank you, everyone. See you tomorrow. Bye. And be online so that they can also join the session and you can attend that session as well. So I'll be logging off now.